Section 1, the circuit board. Now we're going to go into the assembly. First, we're starting off with the circuit board you received in the kit. As you can see, it has an assembled side, a pre-assembled side with surface mount devices. That's all the hard science that went into the making of this. You're going to be soldering the parts onto the flat side that doesn't have any components on it, using the parts from this kit. It doesn't look like many, and it shouldn't take very long. The last time I tried recording this video, it took only about 35 minutes. And most of that was just talking my way through it. So first, the notes and cautions. You're only placing the components on the surface that's not assembled already. Therefore, all of your soldering is going to be happening. If you place this through, all of your soldering is happening on the side with all the other little chips. So you need to take extra caution not to touch the other little chips and components on here with the tip of the soldering iron. I've done what I can to move those parts away, but the space is it's used efficiently, which means it's going to be tight for your soldering at some points. I would not use a large tip on your iron. I like a fairly small wedge or angled tip. In any case, now we're going to go to take care to avoid the components. As you do your soldering, you're going to want to examine the joints and make sure you don't have a bridge across the holes for the capacitors or the connectors or anything for that matter. Solder bridging is bad in general. Additional cautions. The capacitors, as you see, have a white stripe on the side of them, electrolytic capacitors and the other through-hole types. They have white stripes on them, and you want to make, that's the negative side, and you want to make sure the white stripe on the negative side lines up with the white arc on the board side. So if you notice putting it through here, you notice the stripe goes right over the board arc. So they line up. In addition, there are plus and minus signs on the different portions of the markings for the capacitors outside of where the capacitor sits, so hoping there will be even less chance of you messing it up. For this one capacitor that I already put through the board, if we zoom, well, I don't know if holding it up will help. If you look right here, you'll see there's also minus and plus signs where the legs are coming through the board. And also note that the negative leg, the side with the stripe on it, has the shorter leg. So there's two indications on the capacitor itself, a shorter leg for negative and the negative stripe, as well as additional markings all over the board. So if you need to double and triple check those before and after you put them in and solder them, because if you put them in backwards, you're going to end up shorting that and the board will not work. So let's skip ahead and get to the connectors. These are JST-XH. They're fairly standard connectors. And if you will see, they're through-hole board mounted from the legs coming out of them. These will receive the connectors from the loads, your lights and the USB and the battery and speaker and such. There is a next version of the board coming out, 2.7, that I've modified and will start including these smaller connectors. These are the JST-PH connectors, and the reason for these is the USB-C connectors and the speakers come with these smaller connectors already with the other housing, the female housing. So if you have a 2.7 board, and you will know it by looking in here, and let me zoom. I'll try to do this live action shot. Zoom. Yeah, there we go. That's not bad. You can see right up here it says V2.6. If you get a V2.6 board, you'll need to solder a resistor in series with the LED that goes on the top, and it's in the instructions in this guide. Also, if it says 2.7, you do not need that resistor, and you can just omit that. I've already included that resistor for that version on the board. And if it's a 2.7 board, you will have the opportunity to be one of the first to use one of these smaller connectors for the USB connector here, as well as for the speaker right there. So starting with the connectors, wire connectors that get mounted on the front of the board, I am going to place them all on here at one time. Now you want to make sure, one, you're putting them on the empty side of the board, where all the components you are putting on should go, and also that the open portion of the connector here faces the front of the board, closest to you as you do this. It's important for polarity purposes because the wiring is very, it's tightly instructed later exactly how to do the wiring and the soldering and making sure the polarities are correct all the way through. There we go. So we've got all the connectors on there on the board. We've got all the open sides towards the front. So at least this portion of the polarity will be correct. Next, I'm going to try using masking tape. I'm going to put it over the connectors. And this is just an easy way I found when I recorded my test video. I can put them on there. It holds them in the board. And now I can just move the tape away. And I've got all the connectors in there and nothing fell out. Nothing went overboard. Excellent. There's no cries for help. No life buoys needed. And I'm going to use a little bit of blue tack there to hold everything down and try to center this for the view and get the iron fired up. For the ironing, I presume most people trying to do this have used a soldering iron before. If you're fairly new to soldering or it has been a while, the goal is to heat both the pad that you're going to be soldering as well as the pin that you're soldering together. So both portions, it's ideal if you can heat them both up and then apply the solder. First I'm going to I cleaned the tip, and then I'm going to dab a little solder on the tip, which helps conduct the heat. And now I'm pressing it against both. Oh, I see the autofocus is working against me there. Yeah, that autofocus is definitely working against me. I'll try to keep my hands out of the video as I can. And I'm just doing one set of pins at a time. Here we go. And just set the tip there at the junction. And then let it heat up. Add a little bit of solder. Leave the tip there and then take it away. It's a fairly smooth operation. It might take a little bit of practice if it's been a while for you. And again, I don't know if I'm going to leave all this portion while I'm doing this because it makes the video longer, and I figure like you guys want to get down to business and not have to listen to me. Because it's like having to listen to a doctor on one of his rants. It's like, okay, I get it. Mom, Dad, I shouldn't be committing genocide. Just leave me alone already. Let me go back to my room. There we go. As you go, you want to make sure there's no solder bridging. That's a solder crossing between the two pins, the two legs. And I'm going to zoom in here some so you can see how some of that came out. I don't know if it autofocuses at the same time, but if we tilt the board, you can see you want a little volcano from the pad going up the lead or the leg that we soldered. And we'll see it from the other direction there. That's not terrible. And all those joints look good for the time being. If you see something that's a little cattywampus, you can always just go ahead and hit it with the iron again, heat it up, and then let it cool off. It's called reflow. And it's never a bad thing. You use it a lot when you're trying to improve your solder. So here we go. I want to make sure I'm putting the long leg through the hole that has the plus sign next to it. And the leg with the negative, the leg with the white arc on the board matches up with the white stripe there on the capacitor. So you can see that's nice and great. So I'm just going to stick all of them in at one time. And long leg through the plus. There we go. And then I'll do a magic flip without it doing an actual somersault. If the legs are a little bit bent when they come, that's totally normal. And they are all good. All the capacitors were tested prior to packaging to make sure that they read properly on a meter. I actually try to test all the electronics before it gets packaged up. Okay, all 5 of the capacitors are on the board, and now we're just gonna flip it and just turn it and carefully lay it down and all. Oh, look at that, they're all still in there. Excellent. Now I'm gonna get the soldering iron out. I'm gonna double check before I do any soldering. I want to double check and look at the length of the legs. So the short legs are in the holes with the minus signs next to them, now that I'm looking at the other side of the board. Again, the double and triple checking will save you a lot of grief later. Then I'll get a little bit of, I cleaned the tip, get a little solder on there, and now it's time to go to town. What I'm going to do is just solder one leg of a capacitor at a time, because doing this method, it's a little bit sloppy how the capacitors are going to be on there on the other side. So I'm just going to do one leg at a time and then get the capacitors settled all nice and pretty, and then hit the other legs. Again, be very careful not to touch other components on the board with your solder tip. Now, if we look at that, we'll flip it over. You see they're all in there. They're all attached. Other people like to spread the legs of the capacitors or LEDs or whatever you're soldering. They like to spread them out so it kind of holds it in there. I've done that, and I find unless I spread it pretty hard, it doesn't stay against the board anyways and still needs to be reworked. So this way I end up with straight legs that I can cut off and reuse for later purposes. So what I'm going to do is just now have my finger tapping and holding against the top of the capacitor while I touch the iron to the already soldered leg, and heat up the leg and just make sure that the cap settles on there. And now maybe you can see it's nice and flat against the board. So I'm just going to turn this board around and do that for all the others. Here's the have my finger against the cap, reflow a little bit, and then once the cap is settled, go ahead and take the tip away. And you can see that one's nice and flat against the board. And let's hit the other ones here, and we'll try to move on a little bit faster. There we go. I felt it settle, and then I take the tip away. And heat that solder junction. There we go, and let it cool. Let it cool for a second before you move your finger away. Otherwise, the part may start slipping out on you. Okay. And they didn't move a lot, but now we are assured that they are all sitting nice and flat, straight on the board, and they are flat to the surface there. There you go. So it's all nice and pretty. And the next step is going to be clip. Oop, we're not going to clip legs because we haven't soldered the other legs yet. All right. Yeah, I should not try to get anything perfect on here because it will just take time and look ugly anyways. Okay, tip in there in that tight space, let it flow, and then take the tip of the iron away. Heat the joints, add the solder, take it away. Heat the joint, tap it with the solder. There we go. Here's a little bit of a tricky one in here. I like using my magnifying lamp because I'm an old dude, and everything's better with magnification when you're working with electronics. Okay, so all the joints are done. And the next thing is, last thing for the capacitor is to clip off the legs. You do want to protect the leg, keep it from flying away. It will fly away on you, and you don't want that flying out. So just a tip of a finger on the end of it as you cut. I like to use flush cutters, and you want to cut that close to just at the top of the solder joint, so that the legs will fit, and so the whole board will slide in and fit into the project later on. If the legs are too long, you'll have to end up trimming them later anyways to be able to slide it fully into the TARDIS, into your TARDIS, before you take that machine out for a ride. There we go. It goes pretty fast. Like I said, I like to save these legs for later for other purposes. Thank you. And there you go. Capacitors and board and the wire connectors are all on here now. Next up is the blue trimmer. This trimmer is you normally use to adjust voltage. I use it in this case to adjust the volume every time before the TARDIS, the brain, play an audio clip. It checks the position of this trimmer, and it will adjust. Then it'll set the volume according to that. But in this case, you don't need to adjust it every time. Just adjust it when you're first doing final assembly and setting up, and get the audio volume, the volume just right, how you like it, in wherever it's going to be. And then it'll be at that level whenever you do it in the future. So I just use a little bit of blue tack to hold that trimmer in there. And this is a pretty basic part and pretty easy. So I'm just going to heat that joint up, give it some solder, let it flow, take the tip away. Solder it, take the wire away, take the tip away. It's pretty repetitive. I like to have some music going when I do this. But I don't want to do it right now because then you won't be able to hear it so well. I recommend adjusting this potentiometer, this trimmer. Rotate it to the right or clockwise all the way, and then back it off about a quarter. That way, when you do the final assembly and check the volume as it plays, it'll probably be pretty close to where you want it. You don't want it maxed out, because it'll do weird things when it starts playing, and not good things. They do stuff like rip your ears out, or it'll get crackly, or start breaking up the audio. Now we're doing the header pins for the audio mount. You see they go right there near the front of the board. I tried to put most connectors at the front for ease of access. And I'm going to stick some blue tack on here to keep the pieces in place as I do an initial solder. It might not be square right now when I do that this way, but I'm going to solder one leg of each header to hold it in place. And then I'm going to turn it over and correct. I'm basically looking to make sure that the header is against the board and not lifted from it front or back, as well as make sure that it is square. You want it 90 degrees square to the board so that the audio module you're going to plug in later sits in it well without stressing the joint. So now I'm going to correct. See, this side's leaning a little bit to the right. So all I'm going to do is heat up the joint from the bottom side and press in to make sure it's against the board and align it while that joint is hot. See, it slipped in a little bit and it's squared up. Take it away for a second, and now it's nice and solid, square to the board. And do the same thing with the other side. There we go. I felt it slip in a little bit further. So it's reasonably square. If it looks reasonably square, then no worries with the audio module when it goes in. It doesn't have to be exactly precise. You just want to get close enough that it's not going to screw things up. Okay. And just a little, heat up the joint. Just add a little solder. You don't need a whole mound. You can end up using so much you're either going to bridge or it's going to look like a big blob. And you just want that nice, clean little volcano. And that's one side done. I'm going to reflow the front one just to make sure it's good. Add a little solder. There it goes. Everything's looking pretty. And trying to get this over the board where you'll see it again. Here we go, and let's get the other side. Yes, I do have an solder exhaust sucker I made. I just don't end up using it very much because it's kind of inconvenient and it's definitely loud if you're trying to shoot video. So I'll just hold my breath for the next half hour. There we go. Audio module is in there. There's a correction. The headers are in there. It's fairly square. It's against the board. That part's done. And now we're going to get to the last couple items, the header pins. The 1x3 header pin goes here in the where it says touch right there. You want to make sure you have the longer side of the header pins sticking out the top and the short side that goes through the board to get to do the soldering on. And let's see, gonna add some blue tack again. It's just putty. That's all it is. It's reusable putty. And it's immensely helpful to hold things in place when you've only got two hands and you're trying to manipulate 6 things. Yes, it was danger close to my fingers. I get it. I probably should have checked if it's square before I did all three of those. And of course it's not. You probably see it's angled off right there a little bit. So what I'm going to do is put on my special glove, not to be confused with my love glove. This will protect my fingers. What I'm going to do is just keep this glove, the finger pressed against there while I heat up the soldered side of it a little bit. And then I'll make sure which way I need to go. And then I'll just alternating heating up the different joints, the 3 different joints. So I think it's one of those things like with the audio header pins. Yeah, it's close enough. With the audio header pins, solder one and then check the level and then move on after you've got it squared. There we go. And the next piece is this 1x2 header pin. This goes on the side of the board And you want to make sure the long legs are sticking out the top and the short legs go through for the soldering. I'm going to hold it in place in this case to get it started and see if it can... there you go. Okay, I'm going to hold it in place. I'm going to try not using the blue tack and not using proper technique. I just do that a little bit there to get it to hold into place while I then check the level. And that pin actually looks like it's in there good. So I'm going to set it down, and I'm going to hit the other leg after I remove my special glove, not to be confused with the love glove. There we go. Now I'm going to hit the other leg, get that soldered in nice, and then go back to the first one. I'm just going to reflow it a little bit. There we go. So there we go. That's the last two pins. I like to put the jumper. This jumper goes on those last two, the 1x2 pins you just saw me do. It prevents when you first power on the board and do your testing. It prevents power from going from the battery or USB connectors down here into the rest of the board. So if you've got something reversed or shorted or something screwed up already, having this jumper prevents anything from going wrong further down with the rest of the board on the underside. It's your last line of defense. But for the time being, I like to put this header jumper on there so we don't lose it. We'll play with that again at the end of the build.